We are considering the next question. Consider the plot of f of x versus x as shown below. So there's a graph. Suppose f of x, capital Fx, is equal to integral from minus 5 to x f of y dy. Which one of the following is a graph of capital F of x? So we have four options, four signals. One among them will be capital of x, which is nothing but the integral of small f of x from minus 5 to some x. Okay, so um, in this question, if you consider small f of x, right, it is symmetrical, right? We have a negative part here, a positive part here, which is anti-symmetrical about the y-axis. So I could tell you that f of x, when you start from minus 5, right, when you start from minus 5, because the integral is from minus 5 to x. Okay, so when we approach from minus 5 towards positive x, this signal has equal negative and positive area. Why did I mention the term area? Because of course you know integral of a function means area under that function. Okay, so here the function of f of x, and integral f of x over minus 5 to x means area under this curve from minus 5 to x, wherever it is. Okay, so as we advance from minus 5 to x, we are just calculating the area under this graph. Okay, so before minus 5 at this place, what is the area? Area will be 0. Okay, so I am plotting area 0. Then after minus 5, this is a negative area, right? This is a negative area. I can make you sure that this is negative area and this is equal positive area because it is anti-symmetric. Okay, equal and opposite area. Right. So after minus 5, the signal amplitude increases to negative. So negative area increases, right? Increases and increases and becomes maximum at 0, right? At 0, this area almost ends. That means its area becomes almost constant, right? Now what happens is, after x equal to 0, at this position, again we are advancing towards positive x direction. So now positive area is increasing, right? Positive area is increasing. Here we have a negative area up to this portion. We have a negative area here. Now a positive area is getting added. But what happens when positive area is added with this negative area? This negative area reduces, right? So the output, or the graph, goes equal and opposite, right? And finally at minus 5, this graph is, this positive area just becomes equals to the negative area. Yeah, right? At positive 5, x equal to 5, the positive area just equals the negative area, so the resultant is 0. So after 5, the resultant is 0. Okay, so this one, this graph more or less represents the area of the function small f of x. So I think answer option C will be the correct answer you have to follow, right? And in the meanwhile, why should we avoid option A? Because in option A, at x equal to 0, the area is 0. But it is not so, right? At x equal to 0, we have the area of this whole negative compartment, right? Negative value. So there's a negative area there, but here they have shown the area is 0, so this cannot be option. The same is the case in B also. At x equal to 0, they have shown that the area is 0, which is not correct, and option C is the correct option. And what about option D? This is never 0, never acceptable, because we have area 0 at this portion. It is definitely not 0 in the question. Okay, so the correct option is option C.